take a look at ARP and the routing tables of the network that we saw this animation of the frame and the packet moving to it. What I want to do is I want to look at the ARP table on the PC, routing table on the PC, as well as the ARP and routing tables on the routers themselves, so we can see how this process is happening. So to do that, I need to get into command prompt. So to go to command prompt, I click on Start, and then I type CMD in that search field. Now, when working with ARP, oftentimes we like to flush the ARP cache. And to do that, I need to be in administrator mode. So I have to right click on the CMD option here and choose Run as Administrator. And then I hit yes here, and what that'll do is it will allow me to access the command prompt as an administrator. We don't need to clear the ARP cache very often. Ross, what the heck's an ARP cache? Well, an ARP cache is the location where we store the MAC address to IP address association. And to view it, I issue the command ARP-A. I do not need administrator privileges to view my ARP table. However, the ARP table or ARP cache is temporary. It only lasts for 90 seconds to 3 minutes or so. And if we want to clear it so that it's fresh, what we can do is we can issue the ARP-D space star command. So ARP space -D space star. And that will clear out any entries in our table, leaving it blank. I can just press the up arrow key there to bring back the previously used command. And when I have ARP-A now to show me my table again, I only have this one entry in here for my broadcast address. And that's a standard address that's included in my ARP table on a Windows workstation. Notice that the MAC address is all Fs, the broadcast at layer 2, and then the IP address at layer 3 is also a broadcast address. So the broadcast at layer 3, broadcast address at layer 2. We don't use those very often. At any rate, let's send that ping message over to 10.0.0.10, just like we did in the animation. We'll get our replies. This means that we sent a packet there and we got a reply back. And now let's look at two things about how that message got there. First, let's take a look at the routing table. So if we do route space print, so type route space print and press enter, and this is going to show you the routing table of our workstation. Now the routings table on a Windows workstation is notoriously disastrous. There's tons of information here. Most of it is not relevant. So let's take a look at what we need to pay attention to. There's really only two networks that are important in our routing table here, and I'll highlight the routing table, which is this area right here. So this is our IP version 4 routing table. The two networks we care about are this top network, 0000 with 0000 with a gateway or router address of 192.168.10.1. The other network we care about is 192.168.10.0, as that is the network that our particular workstation is directly connected to. The rest of these entries, Windows uses for their own purposes. The ones that we need to be concerned about are the network that our workstation is attached to and the default route. Now, the default route is always going to have 0000 as its destination address and 0000 as its mask. When we ping 10.0.0.10, what will happen is now the PC will look up in its routing table and find out which route to take to reach 10.0.0.10. And it looks up in its table, and the only two routes that it knows about for network-wise that are useful here are 192.168.10.0, which is not the route to 10.0.0.10, and then this other one, the default route, which covers everything except 192.168.10.0. So the PC then chooses the default route to send the message to the router so that the router can then forward it to the right spot. In order to do that, just like we saw in the animation, we are going to take that packet with a destination of 10.0.0.10, find the route we're going to take, in this case the default route, which has a next hop address, or the router IP address, of 192.168.10.1. We are then going to ARP for 192.168.10.1 to retrieve its MAC address. Once we retrieve its MAC address, we can then build the frame to send to the router. So let's check our ARP table now. I did send my ping before I took a look at the routing table. If I type ARP-A now to view my ARP table, we'll see there that in my ARP table, I have 192.168.10.1 and its MAC address. Now the MAC address here is different than the MAC address on the slide, and that's namely because we had to construct the slides before I knew what the MAC addresses of my equipment were. But ultimately, you can see here that my workstation has resolved the MAC address for its default gateway. This way now, when I send the frame out, the frame is going to have a destination MAC address of 00225552CB56, and it's going to have a destination IP address of 10.0.0.10. Notice that it did not ARP for 10.0.0.10. It looked up in the routing table to find out where to send the packet, and then it ARPed the next hop address, in this case our default gateway's address, to find out what its MAC address was so it could build the frame. Let's minimize this window and go take a look at our router. So I'm going to launch PuTTY for that and log in via Telnet. My router's IP address is 192.168.10.1. I'll hit open. We will go into privileged mode. And here I'm going to issue the command show IP route. When I look at the routing table on a Cisco router, it looks a little bit different. As a matter of fact, it's much cleaner than on the Windows workstation, as we don't put as much extra stuff in here. Up at the top of our routing table are codes. It's our key, basically, for looking at the routing table. The routing table itself is only these couple lines down here for our current case. As we add routes to our routing table, it will grow. And as your network size gets bigger, of course, the number of routes in your table gets larger and larger. In this small example, I only have 3 routes. So let's look at those routes. So these first 2 are directly connected to my device. So I know that for a couple reasons. One, it says network 192.168.10.0/24 is directly connected to fast Ethernet 0/0. All right, so it's telling me, I just have to read the sentence. So the network that my PC is connected to is hooked up to fast Ethernet 0/0 on the router. And I know it's directly connected for 2 reasons. One is that it says directly connected here. And 2, it says a C here at the beginning of the route table entry. And if I go up and look at my codes, I see that C means directly connected. I then have the network that connects the 2 routers together. And that's connected via fast Ethernet 0/1. And that address is 172.16.10.0/24. What the heck is a /24, Ross? Well, we're going to learn about that when we do subnetting. But the /24 is another way of writing the subnet mask, and it's called CIDR notation. And really all it is it's a way of just counting the number of network bits that are in the subnet mask and then writing it as that instead of a long number. So a mask of 255.255.255.0 ends up to be a 24-bit mask because 255.255.255 is 24 bits total of ones, and then 8 bits of zeros. We're going to cover this in much more detail when we get into subnetting, so if it doesn't make sense right now, don't worry about it. Just know that /24 is a 255.255.255.0 subnet mask. Okay, so we have this packet in the router now, and we've checked the frame, and the frame is correct. It's destined for the router. So the router grabs the packet out of the frame and throws the frame away. Then it looks at the destination IP address and consults this table. And we notice that 10.0.0.10 is the destination address, and we actually have a route to network 10.0.0.0/24 here, which 10.0.0.10 is a part of network 10.0.0.0/24. So we look up that route, and that route says, oh, we need to send that packet. If it's destined for network 10.0.0.0, we need to send that packet to 172.16.10.2. So in order to do that, we have to create a new frame. We can't use the IP address to get it there. Remember, we have to build that frame. So we have to ARP for the MAC address of 172.16.10.2. On a Cisco router, we can look at the ARP table by doing a show IP ARP. And when we do show IP ARP, we can find out what the MAC address is now for 172.16.10.2, which is 001D71D7-9E5F. So now we can use this to put the destination MAC address in the frame. We're going to put the source MAC address as our fast Ethernet 01 interface, as that is directly connected to the 172.16.10.0 network, which is the network that we need to forward our frame to next. Remember, that's the next hop here. So we put it inside of that frame, forward it on to router 2. Router 2, let's log on to router 2. Open up a telnet session there, 172.16.10.2 is that IP address. I have to type the password in correctly. There we go. We'll go to privilege mode. And here we can do show IP route. When we do show IP route on this device, we're going to see that network 10.0.0.0 this time is directly connected to fast Ethernet 00. So that frame comes into this router 2. Router 2 grabs the packet out of the frame, throws the frame away, looks at the destination IP address, which is 10.0.0.10, finds out that 10.0.0.10 is directly connected. Since it's directly connected, it's going to ARP the IP address, the destination IP address, directly. So if we look at the ARP table on here, we're going to find out that IP address 10.0.0.10 has a MAC address of 0.0.0C29AB5D16. So this is looking at the devices directly to see how they're doing that route table lookup, what they're looking at in that routing table, and then it's going back and it's doing the ARP, and we can use the show IP ARP on the router to see the MAC address to IP address correlation. And on the PC, on command prompt, we can issue the ARP-A command in order to see our MAC address table there. To see the route table, we issued the route print command. This wraps up the video of watching a packet move through an internetwork through frame encapsulation. I really enjoyed doing this one. This is my favorite stuff to do. I look forward to seeing you in a future train signal video. Thank you.